Good morning, everyone. In our today's session, I am your teacher, Dr. Arpita Das, Assistant Professor, Adamas University, Department of Biotechnology. We are going to discuss about the next part of bioprocessing. So before going to start, I'm going to share my slide. I hope that the slide is visible to you all. So we are discussing about bioprocessing, the art of tuning science into success. And in our previous class, we have already studied about that, the introductory part, as well as the application of bioprocess in the help of or to improve the mankind. So in today's class, we are going to start with the next step. As we have already discussed that the bioprocessing is having mainly 3 steps: upstream processing, bioreaction, and downstream processing are the main 3 key part of bioprocessing. So first, we will be discussing about upstream processing. Here, upstream processing of bioprocess technology, you can see a diagrammatic representation here. It's a diagram of a bioreactor. It is a huge vessel. As I have already said, that the bioprocess is the heart of, bioreactor is the heart of bioprocess technology. So this is an example of a bioreactor with plenty of ancillary support and all. We will discuss that later. So upstream processing, as we have already said, that upstream processing is nothing but we need to prepare. It is a preparation part of bioprocess. It's a preparation part of sudden production. It's a preparation part. So regarding this preparation part, yes, we need to make ready that living organism. We have to create, or we have to prepare the microorganism for the process. Then we have to create, or we have to prepare the food for the microorganism. Then we need to optimize the ratio, that for how much microorganism, what amount of food is best. And then we have to put everything together into a bioprocessor. So these comes under upstream processing. Though just by listening this, you can understand, you can think it is a very easy process, but no, it's a complicated steps. And it's not one step, there are many steps which has to be performed simultaneously. So in bioprocess technology, we use living microorganism or their component to produce valuable product, to perform or to create a specific product. And this in this bioprocess technology, the upstream processing plays an important role. If that means these are the investment part. Like in upstream processing, you are supposed to invest your money. You are supposed to buy food for the microbes. You are supposed to buy microorganism, and then you need to modify it. All these things are investment. Then you need to put all this thing into a bioreactor, again, an investment. Then you are supposed to do downstream processing. Regarding that, you have to choose certain cutting edge technologies, again, an investment. Then finally, you will get a product which you will get, you need to sell it, and then you will get the revenue. So you have to choose your product, or you have to choose your material very wisely, so that you can get much profit. So bioprocess technology is concerned about a product. And whenever we are talking about a product, that means at the end, you need to sell the product, and profit will be your high priority things. So we have to take care regarding those also. In our last class, we have already discussed that what are the applications. There are 10 applications. We have already discussed those things. Those application includes that pharmaceutical industry, includes food and beverage industry, where we can use bioprocess technology. There are bioremediations. Bioremediations means there to clear or to clean the environment. To clean the environment, microorganisms are being utilized. So their bioprocessing can be utilized, as well as biofuel production. Biofuel, that means ethanol. Those things can be get produced using bioprocess technology. Then another industry is there, which is known as enzyme production industry, where various types of enzymes are being produced using bioprocess technology. As an example, we can talk about like uni enzyme or carbozyme. When you go for a wedding ceremony and all, we eat many things, and when you come back, we feel like, okay, I'm not feeling well, we are feeling heavy. That time, generally, we consume some medicine that is nothing but enzymes. We consume certain enzyme named as unienzyme or carbozyme, those kind of tablets or medicines we used to take. What it consists of? It consists of nothing but enzymes. Enzymes which degrade the carbohydrate. Yes, amylase is the name of the enzyme which degrade amylose, which is present in rice, chapati, biryani, like whatever carbohydrate you have consumed that is in your stomach. Now you are adding certain enzyme to break it down. Simple. So we are just consuming different enzyme in a mixture in a product. So some industries are there who has produced this enzyme. Okay. So those enzymes are being utilized. So enzyme production is one of the most important area where bioprocess is being utilized. Okay. Then we can talk about biopharmaceuticals. Biopharmaceuticals means, yes, medicines has to be produced in a bulk quantity. So bulk quantity production means the industry is dependent on a bioprocessor. The industry is dependent on a bioprocessor. We can talk about therapeutic proteins like insulin. That is been an example of biopharmaceuticals, which is being produced using bioprocess technology. Yes, the next example include wastewater treatment. In wastewater treatment, organic waste, sewage waste are being removed, and various types of microorganisms like different fungi, certain algae, those are being utilized to remove the waste using certain bioprocess technology. There are different type of reactors are being utilized in that method. Then bioplastic is another key role area where we can use bioprocess technology, vaccine development, and at last we have talked about agriculture. Yes, in agricultural field, we also can use this bioprocess to increase the soil fertility. We can create certain biological pest control using bioprocess technology. So the application is vast. The application of bioprocess technology is really vast. We have that idea that, sorry, okay. So here are a few examples is been written in the slide. You can see biopharmaceuticals, biofuel, enzyme, bioremediation, and many more extra, which I have already discussed with you. So that has to be listed by you. So do certain tasks. Please jot down or please try to create your own note on application of bioprocess technology. I have not given all the points in this slide so that you can try to remember and try to write in your own notebook to create your own note, or else you will not use any book or any other source for preparation of your note. Okay. So we are talking about upstream processing, and regarding upstream processing, first we are supposed to think about one thing, which will be that media formulation. First, we'll be talking about media formulation. Like, what is media? Now we need to understand what is media. Yes, the food for the microorganism is named as media in this bioprocess. Now, what food microorganism consume? Microorganism consume various type of food. Like for us, we eat carbohydrate, protein, fat, many things. Similarly, microorganism, they also happy to have carbon source. They also require nitrogen source. They also require phosphorus source, or different type of things, hydrogen, oxygen, that are also being required by the microorganism for their growth. Okay, so microorganism will grow very well if they get all these things in a proper amount. So happy microorganism will produce much product for me. So what will be my aim is to create a happy environment, or we can say scientifically an ambient environment for the microbes to grow. Okay, so we are going to create an ambient environment for the microorganism to grow by providing many facilities, Okay, before going to start that media formulation in a details, I would like to share few points that for the microorganism, what are the main thing to like for microorganism to create or to formulate a media? What are the main thing? Like microorganism require water for its growth. Yes, microorganism require water for its growth. Along with that, they require energy resource. They require carbon. They require nitrogen. They require mineral, vitamin, as well as oxygen as their resource. Yes, there are certain criteria for a perfect nutrient medium. There are certain criteria to create a perfect nutrient medium. And a perfect medium generally yield something. Like, why I'm going to contribute a good medium for a microorganism? Because my aim is to fetch maximum yield. That I would like to create the media in a manner so that I can get highest amount of product. And if the concentration of the product is less, then also I'll not get good profit. So I'll try to formulate the media in a manner so that I can get the maximum concentration of the product at the end. Now, the medium should be in a manner that the medium is having some desirable product, and at the end, the amount of undesirable product should be less. So the minimum yield of undesirable product is fascinated. That means I would create the media in a manner that desirable product should be there, and the product which I aim to get at the end, that should be a stable product. Then I would create the medium in a manner that while making the medium, there should be minimum amount of problem. If suppose I am handling a medium which is very much sticky, which stick with the surface, then it is difficult to remove or difficult to clean. So I will try to create a medium which is very easy to handle. Like while sterilization, it will give less trouble. And along with that, I need to take care of another thing, that the medium should be in a manner that while production, like in a bioreactor, during agitation, aeration, it should create a minimum problem. So the viscosity of the medium, the stickiness of the medium, the component of the medium should be in a manner so that I can get highest yield, good amount of product. The product should be stable and it should not get degraded in any situation, and the handling problem should be less. That means during aeration, agitation, extraction, purification, in those methods, I must not get trouble with that media formulation. That should be our aim. Okay. Regarding, as I said, that water is one of the most important ingredients which help or which is being utilized for this microbial media formulation. It is one of the major things. Like if we don't provide water, microorganism will not be able to grow. If I don't use any water resource, microorganism will not grow. You can see that if this mobile is very dry, if anything is dry, microbes generally don't grow there. But if there is any wet thing, like it is having certain amount of water and all, then microorganisms start growing there. So for the microorganism to grow, they require at least a minimum amount of water to grow over there. So water plays a major role in this. Along with that, some ancillary service like heating of the bioreactor, cooling of the bioreactor, cleaning and rinsing of the bioreactor, that also plays an important role. Okay. So these are ancillary services which require water. So water plays an important role. Now we know that there are two types of water mainly present, that is hard water and soft water. Hard water and soft water. Okay. So hard water, that means in which that inorganic salts are being present. And the soft water is that which is a very soft and it do not contain any salt and all. So which water is suitable for this media formulation? Actually, if you think cleverly, that is soft water. Soft water is mainly preferable for the media formulation because it do not have those heavy metals, it do not have those salt and all, so precipitation will be less, the problem will be less. So suitable water for bioreaction or suitable water for media formulation for a bioprocess technology is soft water. So pH, dissolved salt, those plays an important role while we are supposed to choose water for bioreaction. Now, regarding if we talk about the stoichiometry of growth and production, product formulation, we'll think that carbon and energy source along with nitrogen and other, they generally produce biomass along with product, and some amount of carbon dioxide is also being produced during this process and heat is being generated over there. Okay, so this is a whole stoichiometry or balance of a bioreaction. This is a whole stoichiometry or a balance of a bioreaction. Next, we will be talking about the carbon resources. Like as I already said, that carbon resource plays an important role. Yes, for human nutrition also, we choose carbohydrate, it provide energy. Regarding carbon source for microorganism in media formulation, we can choose carbohydrate, we can choose oils and fats, we can choose hydrocarbons and their derivatives. Yes, but we have to take care one thing, that we are supposed to choose those things which are low cost. Yes, we have to think about a low cost material. Okay. So we have to choose low cost material. Regarding carbohydrate, we can choose starch from maize. We can choose starch from cassava, different cereals, which is not utilized by human. Certain potatoes, which we don't eat. That means human do not consume them. We can choose barley or malts. We can take as an we can take or we can utilize sucrose from sugarcane. We can choose sucrose from sugarcane or sugar beet. We can use molasses, which is a high volume, low value product. So we can utilize them for bioprocessing. We can utilize them for media formulation. We can also use the whey, which is like watery part after we prepare that chena, or we can say that protein whey. So whey water is one of the good source of carbon source. Okay. So maize, cassava, barley, sugar beet, these can act as a good carbohydrate source. Along with that, we can choose oils and fat as a good carbohydrate source, because a carbon source, not carbohydrate, carbon source. Oils and fats is having a plenty of carbon in it, so we can use this very easily. Different vegetable oils like olive oil, maize oil, cottonseed oil. Actually, olive oil is been consumed by humans, so we can remove this. We must choose some thing which are not being consumed by human, because here is our consumer is microorganism and they can consume anything. So we can offer anything which is not being utilized by human. So we can use these kind of soya bean oil, linseed oil. These oil can be utilized as a suitable carbon substitute. Also, along with being a carbon source, they can act as a anti-foaming agent, because oils, due to their surface tension and surface activity, they can act as a anti-foam agent. Okay. So these can be utilized as a carbon source. Another resource of carbon can be utilized in form of hydrocarbons and their derivatives. So hydrocarbons and their derivatives can be utilized as a good carbon source for media formulation, like methane, methanol, in-alkane. Those can be utilized as a good source. So these are all about carbon source, which plays an important role in media formulation of bioprocess. Next important element is nitrogen source. So next element is nitrogen source. Regarding nitrogen source, as we consume protein to fulfill the requirement of nitrogen in our body, microorganism also require same. So we can choose organic as well as inorganic nitrogen source for the media formulation of microbes. Inorganic nitrogen source are low cost. Inorganic nitrogen source are low cost. If you can see that the ammonium salt, nitrate salt, that are not much costly matter, but we can get them in a proper amount. So suppose for a media formulation, I require 3 grams of nitrogen. So I will go for exact amount sodium nitrate I can use. So this is a good source. Like these are the good organic source. Nitrates, ammonium salt, ammonia gas. These are a good nitrogen source. Organic nitrogen source includes different amino acid, different protein, urea. So these plays an important role as organic nitrogen source. Or we can use corn stick liquor, soya meals, peanut meal. So that can be utilized as one of the important nitrogen source for media formulation. Different distiller solubles can also be utilized as nitrogen source. The yeast extract can be another good example of nitrogen source for media formulation. But certain microorganisms require certain important nitrogen source for its growth. As an example, we can say that corn strip liquor acts as a good nitrogen source for penicillin production. So there are certain specific things are utilized for certain specific production. Now, different minerals. Minerals are being required by certain microorganisms for media formulation. So we can use certain salt like KH2PO4, MgSO4, 7H2O, KCl, calcium carbonate, these FeSO4. So these salts sometimes can be added into the media to fulfill the need of certain element, certain minerals in microbes. Certain stress element also been utilized in media formulation. As an example, we can say that manganese. This is a stress, a very trace element which are being added sometime in media to produce certain product like uh, um, protease. In case of protease production, suppose I want to produce certain protease enzyme. For that, I am working here to produce certain media. So in that formulation, I'm going to add manganese in a certain quantity to influence the media so that I can get optimum amount of proteins. Like bacitracin. Like bacitracin, sometimes bacitracin are for bacitracin production, manganese is being used in the production and media formulation. Like if I want to produce riboflavin, in that case, while producing media, some stress element like Fe and cobalt are added into the media in a certain amount, in a very less amount to give a highest or fulfill the production. Now, certain growth factor are also been added to formulate a media, certain growth factor. Now, what is growth factor? Growth factor are those material which is required by the bacteria, but the bacteria is unable to produce them by their own. So those things are called as growth factor. So microorganisms require them, but they cannot create them or produce them. So we need to put them into the media for their need. Like an example, we can say growth factor includes vitamins. Microorganism is not capable to produce all the vitamins. So certain vitamins act as a growth factor, certain fatty acid, few amino acids, sterols. So that has been used as a growth factor. So that also important for media formulation. Now, while we formulate a media, we need to think about buffer, because certain change in pH is not desirable in media formulation, because some microorganisms, they are capable to grow in a perfect pH. Now if the pH of that medium get changed by chance, so their growth will be get hindered. So in that case, certain buffers are being added over there. So calcium carbonate, phosphates, so that can be utilized as buffers resources. Now, for the media formulation, in some cases, we use precursor, we use inducer for the perfect production of the end product. Now, oxygen requirement also plays a very important role in media formulation. Some microorganisms require good amount of or plenty amount of oxygen for their growth. Some microorganisms do not require that much oxygen for their growth. So we have to modulate the oxygen requirement based on the microorganism. Some microorganisms require much amount. For them, agitation is a must. Some microorganisms require less. For them, minimum agitation. Some microorganisms do not require oxygen. For them, anaerobic bioreactor is being implanted. Okay. So these are the most important criteria related to media formulation. Again, we can talk about rheology. The rheology is a characteristics which we can refer as a summation of flow behavior as well as viscosity. So rheology depicts many parameters. Some of them are viscosity, flow behavior, those things. So while we'll be handling with the medium, if it is liquid, its flow behavior is playing an important role in media formulation. Along with that, we have to think about another point, which is called anti-foaming agent. While we are preparing a media for a microbes to grow, and we put it into a bioreactor, then during agitation of nitrogen, mainly foam get formed. So when foam is being formed, that foam has to be degraded. So because there is a certain space in which you have given your form media and you have given your microorganism. Now the microorganism is growing and they are creating foam. Now certain anti-foams are to be added to stop this problem. So anti-foam is one of the most important criteria for media formulation. Some anti-foams includes like oils and fats. So that means they kill the foam or they destroy the foam either in a manner or they reduce the foam formation. That is another manner. So anti-foam plays a very important role in media formulation. Now there should be certain characteristics should be present in case of an anti-foam, that when I will be adding an anti-foam, it should disperse readily and have a fast action on existing foam. It should be active in a very low concentration. While I'll be adding an antifoam, it should act that time only. It must not take some time to accustom with the situation, then it will start working. No. So it should be very fast active and it should have a long acting preventing capacity so that it will hinder the new foam formation. So first, it will be acting on existing foam, and as well as it should have certain property that it will prevent new foam formation. It should not be metabolized by the microorganism. Then microorganism will eat up them. They will eat it up and then it will be acting as a nutrient. So I must not use something which can be utilized by microorganism. And that antifoam agent must be non-toxic to microbes, human as well as animals. And it should not cause any problem during downstream processing. So these are the few basic criteria of an anti-foaming agent. Now, which are anti-foaming agent? Yes, initially I said some oils and fat, but along with that, oils and fat can also act as a carbon source. So every time I cannot use them. Certain alcohol, certain sterol, octal, decanol, esters, fatty acid, and its derivative like glycerides, silicone, that can be act as a good antifoam agent. Okay. So these are all about regarding media formulation. So media formulation is one of the key role in upstream processing. Along with that, so now we are ready with the food for the microorganism. Now what we need to do next is we need to ready the microbes. So in our next session, we are going to discuss about how we are supposed to choose a microorganism, then how we can modify their characteristics or in a positive manner, that how to manipulate a microorganism in a positive manner to get the best product out of it, how to optimize the situation. Okay, so in today's session, we have discussed upstream processing, not whole upstream processing. We have discussed a part of upstream processing, which is known as media formulation. So media formulation or media preparation plays a important role because it is related to all the investment, and how much you invest, that plays an important role at the end. During the time when you get profit, that time you need to understand how much you have invested and which amount you have done your selling and all, and what is the profit you benefited got from that situation. So media preparation plays an important role in this situation. This is a part of upstream processing. So in our next session, we will be starting with strain improvement. Up to that, thank you everyone, and bye-bye.